that's commonly used in data science, but until recently it was cumbersome to use with data stored in a SQL Server database. A copy of that data would need to be exported outside of the security and protection of the database engine in order to process it with Python, and that added complexity and time to any analysis that a data scientist wanted to perform. That all changed when Microsoft introduced machine learning services, which paved the way for running Python scripts right inside of the same server environment where the data was already stored. Hi, my name is Adam Wilbert, and I've been introducing people to databases and the world of data analysis for well over a decade. I'd love to show you how to leverage the power and flexibility of Python scripting in SQL Server. I'll demonstrate how to enable code execution, output status messages, and import data into a script using standard T-SQL queries. Then, after processing the data, you'll see how to export the results back to a valid SQL Server result set and complete the analysis loop all on a single platform using the database management tools that you already know. So join me in my LinkedIn Learning course to see how to process data quickly and securely using Python in SQL Server. To get the most out of this course, I'll expect that you have some experience with SQL Server databases and writing select queries. If you're new to the platform or need a refresher, consider taking my course SQL Server 2019 Essential Training first, and that'll introduce you to all of the topics that you're going to need here. I do not expect that you'll have any prior knowledge with the Python programming language, though, and I'll be introducing the essential components of Python that'll help you work with your data stored in SQL Server from the very beginning. I'll be sharing the various Python scripts and other code files for this course, and you can follow along by downloading a copy from the course overview page. Inside of the exercise files folder is a folder for each chapter of the course, and inside of there are the individual script files. Some of these are named Start, and these will correspond to the state of the file at the start of each movie, and others have the name Complete. This will be the final text that's shown at the end of each movie. You can open these up in any text editor and copy the text out to your clipboard and then paste into your SQL query editor. I'm going to be using SQL Server Management Studio for that, or you could also use Azure Data Studio, whichever one you feel more comfortable with. The other thing that you're going to need in order to follow along is the sample database. For that, I'm going to be using Microsoft's Wide World Importers sample database, and you can get a copy of that from the GitHub page at github.com/Microsoft/SQL Server Samples. Then on this page, I'm going to scroll down and find the link for the Wide World Importer Sample Database version 1.0. And then on this page, I'll scroll down and I'll find the link for the Wide World Importers-full.bak file. This is a database backup file that we can restore on our SQL Server instance. Now I've already downloaded it, so let's go ahead and go through the process of restoring it. I'm going to open up the Downloads folder on my computer. I'll find the file and cut it to my clipboard. Then I'll go into my C drive, into Program Files, Microsoft SQL Server, then the folder that represents your server instance, then MS SQL, and finally Backup. If you see this message that says you don't currently have permission to access the folder, just press the Continue button and you should be let in. Then I'll right-click and paste in the backup file. Then we can open up Management Studio. From here, I'll right-click on the Databases folder in the Object Explorer window, choose Restore Database. We're going to pull this database from a device, and then click on the ellipsis button over here on the right. Next, our backup media is going to be a file. I'll press Add. That'll place us into the backup folder where I put in the backup file that we just copied in. I'll select it and press OK. I'll press OK again, and OK again to restore the backup. When the restoration completes, you'll have your own copy of the Wide World Importers database over here, and you can expand it to see the different data tables that are inside of this database. And now you'll be ready to use that data with Python. Let's kick things off with a discussion of exactly what machine learning services means in the context of SQL Server and how that relates to the Python programming language. First, let's understand what Python is. Python is an open source programming language that has widespread adoption in the world of data science. This is because it includes a large standard library of functionality, but is also highly extensible. Additional libraries and packages can easily be added to gain specific functionality, such as generating charts and graphs, performing image analysis, or conducting sentiment analysis and natural language processing on text. In the past, in order to use Python to analyze data stored in a SQL Server database, data scientists would need to export that data first. But that changed in 2017 when Microsoft added support for in-database processing with Python to all editions of SQL Server. Support for Python joins the R and Java programming languages in a SQL Server feature that Microsoft collectively calls Machine Learning Services. Now, while the name Machine Learning Services implies support for developing advanced machine learning models with your data, and you can certainly do that with Python, it's more simply the ability to run any scripts on your relational data, from basic arithmetic on up. And with the large number of add-on packages that Python supports, the doors are wide open to what you can do with this capability. So don't let the name Machine Learning Services scare you off that this is some high-level, complex, and niche functionality. Support for Python is flexible and can be used by anyone from an entry-level analyst up to a seasoned pro with many years of Python experience under their belt. Python support in Machine Learning Services provides a number of important new capabilities when it comes to processing large amounts of data. I mentioned that processing now occurs in database, and here's 3 reasons why that's significant. First, because data no longer needs to be extracted from the database before it can be processed through a script, you can maintain the benefits of SQL Server's security wrapper. The data stays in the database where access can be controlled, logged, and audited. This is particularly advantageous when working with sensitive financial or personal data where compliance with handling protocols needs to be strictly maintained. Second, copying large amounts of data out of a database could put significant strain on network resources. Because of this, in the past, many data analysts would only process a smaller, representative sample of the data, rather than working with the full data set. Since the data no longer needs to leave SQL Server first, those restrictions are removed, which opens the doors to fuller and more complete analyses. And finally, because the data stays in place, Python scripts can take full advantage of the performance benefits brought by SQL Server technologies, such as in-memory tables and column store indexes. In order to run Python code in SQL Server, you'll use the same query editors that you're probably already familiar with. You don't need any additional software or application development tools to get started. For most people, that means opening up a new query window in SQL Server Management Studio or Azure Data Studio, and just simply start typing the code that you want to execute. Further, you can save your Python scripts right inside of the database as stored procedures, so that other database users can easily execute your scripts without having to write the code themselves. And since Python support is available in every edition of SQL Server starting in 2017, even the free-to-use Express edition, no matter the scale of your application, you can take advantage of Python integration. Support for Python isn't automatically installed with the basic installation of SQL Server, but it is easily added as part of the custom configuration, or you can add it onto an existing installation, which is what I'm about to do. I'm running through the developer edition of SQL Server 2022 on Windows, but as long as you're using any version after 2017, you should be able to follow along to add the required components to your instance. It all starts by coming down to the Start menu and then scrolling down to the Microsoft SQL Server Program Group, and here you'll find the Installation Center with the cardboard box icon. Let's go ahead and start that up. Then I'll switch over to the installation step and choose this first option to add features to an existing installation. Then I need to find the installation media. These are the files that are used to install SQL Server, and they're typically saved on the computer when you originally set up your instance. This folder will be different depending on what edition of SQL Server you have installed. For me, that's inside of the PC, and then inside of my C drive, a folder for SQL 2022, and finally Developer ENU. If you find that you no longer have the installation files for SQL Server on your machine, you can download them again by running the SQL Server installer and choosing the third option to download the installation media. So I'll select that folder and press OK. After a moment, it brings us to the setup workflow, and we just need to progress through this until we get all the way down to this section called Feature Selection. So I'll go ahead and press the next button here. That'll run some tests. Once that's done, I'll press the next button. Here, I'll choose the option to add features to an existing instance of SQL Server 2022, and I'll choose my instance name, which for me is just the default of MS SQL Server. You can use this drop-down menu to choose whatever instance you want to work with. Make sure you remember this name because we're going to need it again in an upcoming step. Go ahead and press Next. Then I'm not going to install the Azure extension at this time, so I'll turn that off and press Next. And finally, that brings us to the feature selection page. Here, I need to choose this box that says Machine Learning Services and Language Extensions. Now, starting with SQL Server 2022, Microsoft no longer includes the Python runtime itself, so we'll have to add that in a few moments. If you're working with older versions of SQL Server 2017 or 2019, then the Python runtime files are included in this installer, so you'll also want to check the box for Python that you'll see nested right down below. I'm working with SQL Server 2022 though, so I don't have that option. Okay, let's go ahead and complete this feature selection step. I'll press the next button there. I'll accept those proposed changes and press Next, and finally install. The installation will just take a few minutes, and when it's done, you can go ahead and close the installation center, as well as this window there. Now, if you're on SQL Server 2017 or 2019, you're all set. You'll probably be prompted to restart your computer, so do that now, and then you can move on to the next video. For anyone working on SQL Server 2022 or later, like I am, we need to add the Python runtime files ourselves, so we have a couple of more steps to go through. First, head over to python.org/downloads. This tells me that the current version of Python is 3.12.0. Yours might be newer. Now, SQL Server specifically requires Python 3.10, so don't download this version here. What we need to do is scroll down on the page to the section called Looking for a Specific Release. Then in this window, scroll down again until we get to 3.10.11. This is the most recent version of Python 3.10 that includes an installer. So I'll go ahead and select that. Then on this page for Python 3.10.11, I'll scroll down and I'll find the installation file for Windows on the 64-bit system. I'll go ahead and click that to download it and choose to keep the file. Then I'll choose the option to open the file, and that'll kick off the installation steps. I'll choose to use a custom installation. Make sure that this checkbox is chosen for Use All Users. Press Next. Then I'll choose this checkbox here to install Python 3.10 for all users, as well as to add Python to my environment variables. Press the Install button and make sure we're leaving it in the default folder of C Program Files Python 3.10. Once that's done, we can close the Python installer. Next, we need to configure a few things to hook the Python runtime that we've just installed over to SQL Server. Now this process is subject to change, so for the most up-to-date instructions, I'm going to refer you to the official Microsoft documentation at this URL, and it's a page called Install SQL Server 2022 Machine Learning Services for Python and R on Windows. Let's scroll down on this page until we get to the section on Python specifically. Now we just need to move through these steps. Well, the first step is to download the most recent version of Python 3.10, which we just did, so let's move on down to part number 2. Here, we need to download and install the latest version of the RevoScale Pi package. RevoScale Pi is Microsoft's bundle of SQL Server-specific Python commands. They handle importing and running scripts on the server. I'm going to choose this option to copy this block of code with these 2 Python commands, and then I'm going to come down to my Start menu and open up a command prompt. Then, instead of choosing it here, I'm going to make sure I choose the option to open up the command prompt as an administrator. Then I'll paste in those commands and press Enter. That'll install the dependencies for the RevoScale Pi package. Once that's done, it automatically loads the command to download RevoScale Pi itself. I'll press Enter again to do that. Next, we need to adjust some read and write permissions for the SQL Server service accounts. So let's head back to the documentation, and we'll find another couple of commands that start with ICAACLS. It's these 2 lines here. I'll press the copy button. We'll switch back over to my command prompt, and I'll paste those in, and it'll start off that process. Once the first part is done, it loads in the second command here at the bottom of the screen. I'll just press Enter again to do that one. Finally, we need to configure the runtime for our specific instance of SQL Server. Let me go back into the documentation and scroll down just a bit to grab that command. And it's this one right here that starts with cd, and then it switches into the program files Python 3.10 folder. Let me scroll over here to the right-hand side of this command, and notice the instance name is the default of MS SQL Server. This is going to work fine for me because I'm using that same default name, but if you're using a different named instance, you'll need to modify this command and put in the name of your server instead, right there. This is good for me though, so I'll just copy it, switch back over to the command prompt, and paste it in. Once that's done, you should see the message that the Python extensibility was installed successfully. You can go ahead and close the command prompt and all of your browser tabs. The last configuration step is to run a SQL command using Management Studio, and then we can finally start running Python scripts on the server. We'll continue on in SSMS in the next video. Now that the computer has restarted, we can load up SQL Server Management Studio and verify that everything works. Make sure that you log into the server with a user account that has administrator privileges. Then I'm going to start up a new query window, and I need to check the status of my server by running the stored procedure called sp_configure. I'll execute this query here, and the value that I'm looking for is on the row that says external scripts enabled. It's line number 10 here. The current config value is set to 0, and that's because the default is to not allow external code to run for security purposes. In order to execute Python code, we need to enable this feature. We do that by executing sp_configure. Then inside of single quotation marks, we'll type in the words external scripts enabled, and then a comma and the number 1. I'll come down to line number 2 and type in reconfigure with override. I'll execute these 2 lines to change the settings on my server, and now we can run sp_configure again to verify the change. Here I can see that external scripts enabled is now set to 1. Next, I want to restart my server instance by right-clicking on it in the Object Explorer window and choosing Restart from the pop-up menu. I'll say yes to this window, yes again, and yes one more time. Now that the server has restarted, we can verify that everything is working by running a couple of very basic Python scripts. To do this, we'll start with the execute command, or exec. We'll then call a stored procedure called spexecute external script, with underscores between each word. This is a SQL Server stored procedure that takes two parameters. The first is the script language that we're using, which for this course is always going to be Python. We do that by typing in on line number 2 the @ symbol and the word language, and we'll set it to the value with the equal sign, a capital letter N, single quotation mark, and then Python. We'll close the single quote and type in a comma and come down to line number 3. If the pop-up windows are getting in your way, you can tap the escape key on your keyboard to get rid of it. The stored procedure uses Unicode data types, so we want to make sure we're using the capital letter N before each value. And you're seeing that right over here, right before the word Python. The second parameter is named script. Once again, I'll type the @ symbol and the word script. We'll follow that with an equal sign and an open single quotation mark, and then I'll come down to line number 5 and I'll close the quote. Inside of these quotation marks will be the full Python code that we want to execute. Let's do something simple. I'll come back up to line number 4, and we'll execute the Python code print, inside of parentheses and quotation marks, the words hello world. We'll close the quote and the parenthesis, and I'll execute the script. I get the error message here saying that the script was expecting an nvarchar value. I'm getting this because I forgot to include the capital letter N right here before the single quotation mark in the script parameter. So you can see moving forward that that's going to be important to include in all of our scripts. Let's execute again, and this time it'll run successfully. After a moment, we get the text hello world output to the messages window. Another thing that we can do is import system information about our Python interpreter. I'll change the script from print hello world to import sys. Then on line number 2, we'll output with the print command again, the value of sys.version. That should import our system information and output the version. In the messages window, we can see that I'm using Python version 3.7.1. And with that, we've successfully installed machine learning services and executed some simple Python scripts right here inside of the Transact SQL query window in SQL Server Management Studio. I'll save the exact syntax of the commands that I've used here in the exercise files as enable python-complete if you'd like to review it. Every Python script that you run in SQL Server is going to start the same way. You'll start up a new query window, and you're going to execute a stored procedure called spexecute external script. This stored procedure has two required arguments. One is called @language, and the other is @script. The language argument will always be set to equals Python. Remember that this is a Unicode text value, so include the capital letter N prefix and wrap the text in single quotation marks. Also be sure to include the comma at the end to separate these two arguments. The script argument also gets specified as Unicode text with the N prefix. Then any Python code that you want to execute will be placed inside of a pair of single quotation marks. So this is going to be the starting point for every script that we write moving forward. The only thing that we need to worry about is what's between these two single quotation marks starting on line number 4. Using the print function, we can have information returned to the message window when we run the script. So for instance, I can say print 1 and put that in parentheses and go ahead and execute this. And after a moment in the messages window, I'll see the output 1. This will be useful for troubleshooting or testing your scripts. You can pass messages that'll confirm that different parts of your script are working as intended. You can also use this to perform simple arithmetic operations. For instance, I could say print 1 plus 1. I'll execute this, and the messages window returns 2. Now, one of the more useful things that any programming language can do is store values in a variable that can be used later on in the script. Python makes that super easy. Unlike variables in Transact SQL, we don't need to declare a data type. Python will just figure it out. In Transact SQL, creating a variable might look something like this. We would say declare the name of the variable, for instance, @a, and we'll declare that as an integer data type. Then we'll set its initial value with the set command, and I'll set the variable a equal to 1. In Python, creating a variable like this is much easier to do. I'm going to go ahead and create a variable called a and set its initial value to 1 up in our script. I'll do that by moving this print command down to line number 5, and I'll come back up here to line number 4, and I'll just type the variable name that I want to use, a, is equal to 1. This will create the variable a, and it'll also set its initial value. Let's go down to line number 5 and set up another variable called b, and I'll set its value to 2. Then in the print command, I can say print a plus b. Then I'll execute the script. The print function returns the sum total of the value of a added to the value of b, and we get the output 3. Since variables in Python do not have to have their data type declared, you can redefine them by simply assigning the variables a new value. So instead of a equals 1 and b equals 2, what I can do is say a equals hello inside of double quotation marks, and I'll say b equals world, also inside of double quotation marks. Now these variables hold text strings instead of integers, but the plus operator, when I execute it, will still correctly join those two text strings together in a concatenation function. It'll join the word hello directly to the word world. If I wanted to insert a space between these characters, I could say print a plus a literal space by typing in the double quotation marks here, and then join all that to b. I'll execute it now, and now I get hello world with a space between the two words. All right, let's go ahead and change this back to just a plus b. So we've seen that the plus operator will perform arithmetic as well as text concatenation. However, Python is considered a strongly typed language, which means that it won't convert between data types on the fly. If I change variable b back to an integer, I'll just change this back to equals 2, and then try and execute this script, I'm going to get an error message. This is because adding a text string to an integer doesn't really make any sense. In Transact SQL and other programming languages like JavaScript, they would have automatically converted the number into a text string, and then return the text hello 2. However, Python won't do that. Instead, we get this error. To fix it, we would need to enclose the number 2 in quotation marks to force Python to treat it as a text string. Now when I execute the statement, I get the output that I expected, hello 2. An alternative to using the quotation marks is to use a built-in function called str, which stands for string. I'll say string of 2 instead of using the quotation marks, and run this again, and I get the same output, hello 2. So as you can see, creating and using variables in Python is much easier than what you might be used to with Transact SQL. Just watch out for the differences in the way data type mismatches are handled, and make sure that you're not combining variables of different types accidentally. There are two forms of looping statements that you can write with Python, and these are useful for executing the same tasks repeatedly. They're known as while loops and for loops. Let's take a look at each one. The while loop is used when you want to execute a block of code as long as a condition remains true. I'm going to start by creating a variable called a, and I'm going to set its initial value to 1. Then we'll start the while loop, and say that while a is less than 10, and this sets up the condition. So as long as the value of a is less than 10, then the following lines will execute. We move into the loop block with a colon, and then indent the next lines 2 spaces. So as long as a is less than 10, I want to print the current value of a to the messages window. Then I want to increase the value of a by 1. We can do that on the next line by typing in a is equal to a plus 1. And that's all there is to the while loop. Python doesn't use the same begin and end statements that you would use when writing a while loop in Transact SQL, and the entire block is defined strictly by the indenting of these 2 lines. So make sure that you insert the same number of spaces for each one. It doesn't necessarily have to be 2 spaces I have here at the beginning of each of these lines. It could be 3 or 4. It doesn't really matter, as long as these lines are indented the same. If I make one of these lines indented 4 spaces and leave the other one set to 2 spaces, then if I try and execute this, you're going to see what happens. I'll get this error message, and in fact, if you read through the output message, you're going to see specifically that it's an indentation error. So I'm going to go ahead and fix the indentation and run it again. This time the code is successfully run, and I get the output numbers 1 through 9. Once the value of a was equal to 10, the while condition is no longer true. A is not less than 10. So the loop exits, and the print and increment lines are no longer executed. So that's a while loop. The other loop that I want to take a look at is called a for loop. This method is used when you want a block of code to execute a fixed number of times. To do this, you'll use an iterating variable, which you can name whatever you want. I'm just going to say for and the variable x. This variable will automatically start at a value of 0 and increment each time the loop runs. Then, as long as this variable is in range of 0 and, let's say, 3, the loop will execute. Just like with the while loop, you enter the block with a colon and then indent all of the following lines in the block the same amount. For this, I'm simply going to print the text "Hello World." I'll press the execute button and take a look at the results. Oh, and it looks like I forgot the closing parenthesis here, and I print command. I'll execute it again. And this time it runs, and I get the text "Hello World" repeated 3 times. So by this you can tell that the range specified up above is not inclusive. The for loop repeats as long as the iterating variable's value is equal to the first number, but less than the second. We can see this clearer by printing the current value of x instead of the text "Hello World." I'll change it to say print x and then execute again. This shows that the first time through the loop, the value of x was 0, then it was 1, then 2, then x is no longer in the specified range, so the loop stops. Another thing that we can do with a for loop is to iterate over the number of items in a group, rather than within a numeric range. So instead of the range 0 to 3, I could do something a little different. Instead, I'll specify a range of in the text "Hello World." Now x represents each letter in the text string, and when I execute the statement, it returns each letter in sequence. Or I can provide a list of Python items. Python uses square brackets to denote a list. Let's go ahead and get rid of this text "Hello World" here, and I'll type in a list of colors. We'll do that by opening up a square bracket, and then each color name wrapped in double quotation marks. I'll separate each list item with a comma. At the end of the list, I'll close the square bracket. So now I have a list with 4 colors: red, blue, green, and purple. I'm going to iterate over this list and print out each list item in sequence. I'll press the execute button, and I'll get the results down below. So those are the basics of using loops in your Python scripts. The while loop is useful when you want to test a condition each time and repeat the loop as long as the condition remains true. And the for loop will repeat a block of code a specific number of times. So far, we've looked at working with values that are hard-coded in a Python script. But I'm sure what you really want to know is how to work with the data that you've already stored in a SQL Server database. There are 3 steps of processing SQL Server data with Python. First, import the data that you want to work with in the Python script using a standard T-SQL select query. Second, you're going to do something with that data using Python functions and libraries. And third, you'll then output the processed data to a result set that SQL Server understands. Let's focus on the first step, importing the data into the Python script. In addition to the language and the script parameters of the sp execute external script stored procedure, there's another parameter that we can add called input data 1. Just like language and script, it takes a Unicode value, so it's going to have the capital letter N prefix. And the value of the parameter is a standard T-SQL select query, just like the ones that you normally use to retrieve information from your database. The results of that select query will get converted into a Python data frame, and then stored in a variable named input dataset. You can then use this variable in your Python script. This brings us to step 2, manipulate the data in Python. The data frame stored in the input dataset variable uses an add-on library called pandas that's widely used for working with tabular data in Python. This library is already included in the Python installation for SQL Server. This means that we can use pandas methods and properties for manipulating the data frame after it's been imported into the input dataset variable. One useful web page that you'll want to be sure to bookmark is this one here, the Pandas Data Frame API reference. It provides a great resource for learning all about the different options that you have available to manipulate your data frames, and many of these will be useful when processing tabular data from SQL Server. Now, if you scroll through the list, you'll see that there's way more here that I can cover in this course, but I will touch on a couple of them so you can get a feel for how they work. In particular, we're going to take a look at this one here called dataframe.iloc. We'll use this one to pull information out of the data frame in the next movie. And finally, that brings us to step number 3, export the data back to SQL Server. To do that, you're going to make use of one more variable called output dataset. When you assign output dataset the value of your manipulated pandas data frame, the results will get output to a standard SQL Server result set when the script completes. This result set will function just like the result sets that you normally get out of any SQL Server query, and you can use them for reporting, or inputs into other functions, or publishing to a website. So those are the 3 steps to the process: import, manipulate, and export. Let's put this information to use by writing some code. The easiest way to start working with a dataset in Python is to first figure out the select query that'll retrieve the data from your database that you want to work with. I'm going to go ahead and take a look inside of the Wide World Importers database, and in the Tables folder, we'll see that there's a table called application.cities. I'm going to create a new query to pull some information out of this table. I'm going to pull out the distinct city name and state province IDs from it. And I also want to order the records by the city name values. I can then execute the query. I get the results down below, and this is the data that I want to work with in Python. Now I can go ahead and select all 3 of these lines and cut them to my clipboard. Now we can start writing the Python script, and we're going to start with the same empty script template that we've been working with. We'll start with exec, or execute, sp execute external script. Then we have our 2 parameters here, at language, and that's going to be set to the value of Python. Next up, we have the script parameter. And I'm just going to leave that one blank here for the time being. And now we're going to add one more parameter. So I'm going to type in a comma after the close of the script parameter, and we'll come down to line number 6. And the next parameter is called @InputData1. Remember to include underscores between the words input, data, and 1. I'm going to set its value. It's also a Unicode character, so I'm going to type in the capital letter N and open up a single quotation mark. And now I can paste in the contents of the select statement that we just generated. I'll finish the parameter by closing it with a single quotation mark here at the very end. The input-data1 property is going to take the results of the select statement and convert it into a pandas data frame and store it in a variable called input-dataset. Now we can use the data in the Python script by referring to the input-dataset variable. Let's start by simply printing the contents of the data frame to the messages window. I'll come back up here to line number 4, and I'm going to use the print function. And I want to print input-dataset. The variable name doesn't have any spaces or underscores in it, and it uses a capital letter I, capital D, and a capital S. Let's execute the Python script and see what the results look like. That'll open up the messages window, and I can see that I have a column for the city name. Python uses zero-based indexing, and we can use these index numbers to pull individual rows from the data frame using pandas data frame properties. One property is called iloc, or ILOC, which stands for integer location. You can use the iloc property by typing a period after the data frame name, which in our case is input dataset. I'll type the period there, and then ILOC. After that, I need to open up two sets of square brackets, followed by the integer that represents the index position of the record that I'd like to return. How about number 7? We'll close the two square brackets, and now I can execute this script. That returns just the single row from the data frame. We can retrieve multiple rows by separating the index integers with a comma. So I'll come back up here after 7, I'll type in a comma, how about also number 10 and number 15. We'll execute the commands here, and I get those 3 records returned. We can also retrieve a range of rows by using only a single set of square brackets. I'm going to highlight all of this here and get rid of it. And this time I'll type in the range of 5 to 15. To specify the range, we're going to use a colon between those two integers. I'll execute the statement, and we get the results here. Notice that the range is not inclusive. It starts at index number 5, but it does not include index 15. It stops at 14. This is similar behavior to what we saw with the for loop in the last chapter. Now, if you're just interested in seeing the first several rows from the data frame, you can use the head function instead of iloc. Go ahead and highlight all of this here, and instead of input-dataset.iloc, I'm going to type in input-dataset.head. Since this is a function, dataframe.head uses parentheses to define how many rows to retrieve from the beginning of the data frame. Let's retrieve the first 10 rows. I'll type in a 10 in parentheses, we'll close the parenthesis, and we'll have that second closing parenthesis here for the print function. I'll execute the statement, and I get the first 10 rows returned from the data frame. For more general information about the data frame, you can use a property called columns to see just what the column labels are. Let's change this print statement to input-dataset.columns. I'll execute it, and I'll see that the two columns are city name and state province ID. And finally, you might also want to know how many rows and columns are in the data frame. You can get that information with the shape property. Now I'll print input-dataset.shape, and in the messages window, we'll see that we have 37,940 rows and 2 columns. So there's a number of different ways that we can start working with the data frame in a Python script. Once you've loaded the input dataset variable from a SQL Server select statement using the input-data1 property, you can then manipulate it with the properties and functions available in the pandas library. The Python scripts that I've shown you up to this point have simply been printing the results out to the messages window, which isn't really useful for SQL Server. In order to pass back the data in a format that can be used by SQL Server applications or reports, you'll need to convert the Python data frame back to a SQL Server result set. To do this, we need to make use of one more variable called output dataset. Here's a script that we wrote in the last movie. It imports a couple of columns from the application.cities table in the Wide World Importers database using this select statement. It does that in the input data1 property of the execute command. Then that data is stored in a data frame called input dataset that we're using up here in the script. we're using the ilock property to pull out 5 rows, starting at index position number 5. We then use the print function to output the results to the messages window. If I execute the scripts, you'll see the result. Now, instead of using the print function, we can use the output dataset variable and assign it the value of the input dataset as processed through the ilock property. I'm going to get rid of the print function here on line number 3, and we'll get rid of this closing parenthesis here at the very end. Then I'll go right back to the beginning and use the output dataset variable. We're going to set it to the value with the equal sign to this result here. Just like with the input dataset variable, output dataset doesn't have any spaces or underscores and uses a capital O, capital D, and a capital S. This time when I execute the script, we're going to get a different result. Now we have a SQL Server result set rather than the plain text in the messages window. We get a result set that has 5 rows and 2 columns. Now, if you're looking closely, you might notice that the column names are missing. The process of converting a Python data frame back to a SQL Server result set drops the column names, so we need to add one more piece to the script to rebuild those column names. This is not part of the Python code. It's a component of the Transact SQL language. In fact, it's an optional component